So yesterday we looked at the relationship between the visual version for division and the parent method or standard algorithm, if you want to use a fancy word, in division. And every time we came to our by, we had nothing left, and just with the numbers that they had given us. And now what we're looking at is what happens when you are trying to divide and you actually don't end up with nothing left. What can you do to get to that place? And I've talked about it in class multiple times where the idea of if you have, just as an example, I'm going to do it up here so it's out of the way. If you have a decimal and then a 2 and then a 1, so say that's like a price tag and it's 21 cents. And if I put a 0 here, it's still 21 cents. Because you have a 2 in the tenths place and a 1 in the hundredths place. And I could just keep going, and if I had a lifetime and any kind of a weird desire like this, I could just keep going all around the length of the circumference of the planet, or my joke, I could just keep making zeros all the way to China, and this right here would still be 21 hundredths, and it wouldn't change that. So we're going to take advantage of that fact with this one so that you can get to the end by adding some place values. So when we take a look at this one right here, I'm going to go with a darker color, make it a little bit more clear. We'll go with this nice pink here. This one, it's saying that we're taking 7/10 and we're dividing it by 4. We're seeing how many 4s can you fit into 7/10. And it's 7 whole, so we know that I can't fit any holes into 7/10. So it's going to be a tiny, tiny number. Here we are, we're making our little discs, 1, 2, 3, 4, 5, 6, and 7. And when we look at this, and we're going to break it into groups of 4. So we have to have 4 rows down here. So we can see how many end up in each row because we're breaking it even so that, remember my statement, everybody gets one. So here's 1, 2, 3, and we need a 4th row down here at the bottom. So here's 3 sets, here's 4 sets. So if we take these 4 right here, and we make sure everybody gets one. 1, 2, 3, and 4. We can see now that we have 3 left over, so these are going to get spread, and they're going to become hundredths. So for every 10th, it's going to be 10 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's one set. Well, let's do the next set. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we'll have to do it again because we've got a 3rd one over here. 1, 2, 3, 4, 5. I'm just going to put it up here because I'm out of room. 1, 2, 3, 4, 5. So now what we can do is take a look at how many groups of 4 we have in this case. So I'm going to go ahead and just kind of make these long ones. 1, 2, 3, 4. Everybody gets one. 1, 2, 3, 4. Here it is again. 1, 2, 3, 4 of them. 1, 2, 3, and 4 of them. Everybody gets one. Here's another group. 1, 2, 3, 4 of them. Everybody gets one. Do it again. Did I go 5 here? I sure did. Be careful, Mrs. Chapman. 1, 2, 3, 4, because everybody gets one. Let's do it again. 2, 3, and 4. Everybody gets one. And then we can just go these clumps. 1, 2, 3, 4. Everybody gets one. And we're at 1, 2, 3, 4, 5. So here's a 6th down here. Everybody gets one. So 4 groups of 6 so far. And here is 4 more. This is 7 in each set. And there's 4 sets. And then there's 2 left over here. So here it was everybody got 1. Here everybody got 7. And then we're going to take these 2 and we're going to make thousands. 1, 2, 3, 4, 5, because it's a hundredth, and we're going to break it into 10 equal pieces, so then it becomes thousands. If you have 1,000 thousandths, you have a whole. But we don't have anywhere near 1,000 thousandths, do we? We have 20 thousandths in this case. 4, 5, right there. And now we're breaking it into sets of 4 again, just like we've done before. And we see how many sets of 4 we can make out of this set. So let's go ahead and do it the way we did before, because it's easy. Because there's 4. So that's, everybody gets one. 1, 2, 3, 4. Messy. Here's another set. Everybody gets one. 2, 3, and 4. And then another set. 1, 2, 3, 4. And then it looks like we got 2 more sets to go. Here's one. 1, 2, 3, 4. And the last set of 4. 1, 2, 3, and 4. And then we see that's 1, 2, 3, 4, 5. So you have 4 equal sets of 5 each. When you divide what we had in the thousands place, which was 20 thousandths. Now let's see what it looks like in the parent style one. I know, and so do you, 4 doesn't go into 0. How many times does it go? None, because it's a nothing. It doesn't fit. So now what we do is we think about how many 4s does it take to get to 7. And I can only go one of them, because if I go 2 of them, it's bigger than 7. So 1 times 4 is 4. You find the difference. And I'm going to think about it the other direction. I know 3, if I had a 3 here, 3 plus 4 would get me 7. And you can also think 4, 5, 6, 7. Count it that way. You can go 7, 6, 5, 4, 3. Do it that way. So here we are. We're starting on the road to China. Here's our next 0. So it is still 7/10. It didn't change it. But it's making it so now we can kind of look at how many 4s here. So if we look over here, here's our 1. Here's a 1. The next one is a 7. Let's try that. 7. And do you see I'm putting it above this 0? Because that's what I'm doing. I'm saying how many 4s go into 70. And if we think here, well, actually not 70, we're down here, we're looking at 30 now, because we've already done part of that 7. We've taken care of that. So now we're thinking 7 times 4, and we know that if we had 7 times 2, it's going to get us 14. 14 plus 14, right? Because if you double that, you get 28. So that would be 7 times 4, also would get you 28. And what's the difference between 28 and 30? Just 2. I think we're moving on to this now, don't you? Because this is 20. So if we put another 0 here on our way to China, around the world, here's 20, and what place value is that 0 in? It's in the thousandths. This is 20 thousandths. We can think this is also 2, the same as 20 thousandths. And what do we have here? We have a 5. Let's try that. 5, 10, 15, 20. If you count by 5s, here's your 20. And now there is no difference, so that is the solution to the problem. We found it. So this whole thing of actually going through and adding some zeros to get to the end of something is the next concept. So let's try this one right here. This is F, so theoretically it's the hardest one on the page, right? Out of this set of 6. Let's try it. And so if we have 8, we're going to do parent style. We're going into 91. I know 8 goes into 9 one time. 1 times 8 is 8, and I put the 1 above the 9. I didn't put it over here because that would be saying I think 1 8 can fit into 91. But that's not what we're doing. We're thinking 8 goes into 9. So we put this part right here, part of our quotient, goes above the 9. Now we find the difference. It's a 1. We bring down the 1 from the 1's place. And this time we're also going to be saying 8 times what? And it's in the 1's place. 8 times 1 in the 1's place. What's the difference? 8, 9, 10, 11. That's a 3. See, we're not done yet. What if we add tenths? And we go to here. And we know that 8 times 2 is 16. So if we double the 16, wait a second. 6 plus 6. Oh, that would get us 32. Too big. So we know it's going to be between 2 and 4. So let's try a 3, shall we? 16, 17, 18, 19, 20, 21, 22, 23, 24. 3 times 8 is 24. And you do that. And I know that 6 plus 4 gets me 10. So therefore, 24 plus 6 must get me 30, right? So if we do our 6 here, oh, we're not done yet. Oh, we have to go to the hundredths place. Oh, crud. I know that 8 times 8 is 64, so that's not going to work. 8 times 8 is 64, which is too big. Let's try the 7 then. And so if you think 64, you take 4 away, you're at 60, you take 4 more away, the other half of the 8, right? Because I'm thinking 7 times 8, 56. And just like we had before, 6 and 4 go together to get you your 10. So I know that 56 plus 4 would get me to 60. So here's that 4. Now we're at the thousandths place. Wow! Here we go. 40 thousandths. Oh, look, we need to put our decimal up here. All right. I know, counting by 5s, that 8 times 5 is 40. And now we're done because we found all the way to the end and there's nothing more to break into pieces. You can't break 0 into pieces. You can't put any 8s into 0. So that's your answer, is 11 and 375 thousandths. So how many 8s can you fit into 91? You can fit 11 of them, which gets you to 88, right? But then you still have the difference between 88 and 91, which is 3. How many 8s can you fit into 3? Well, you can fit 375 thousandths of a single 8 into it. So if you were going to take your 8 and break it into thousandths, it would take 375 thousandths of them. Homework. Here we go. Just one problem. I'm going to ask you to try number 1. And remember, you're going to make your 9/10ths, your dots, your discs, 1, 2, 3, 4, 5, 1, 2, 3, 4 of them here. And then make your solid line, because that's what you have to work with. And then you make dotted lines, 1, 2, 3, 4 of those, because you're breaking it into 4 equal parts. And you want to figure out how many sets go into each of these 4 areas, and that's what it divides into. Thanks. See you tomorrow.